Hi everyone, in this video I'm going to talk about the expanded power rule for exponents. So for number 1 here, we've got 5x divided by y, all raised to the second power. Nothing can combine, there are no like bases, but we can distribute that exponent. So the 2 is going to go to the 5, to the x, and to the y. So I've got 5 squared, x squared, all divided by y squared. Nothing's going to move out of place, we're just distributing the 2. So 5 squared, of course, is 25, x squared, we don't know what that is, and we don't know what y squared is because they're both variables, but that is our simplified answer, 25x squared over y squared. Number 2, x cubed divided by 3y squared. Again, I'm going to distribute the 3 to all pieces. When we have a power raised to a power, we're going to multiply the exponents. So I've got x to the 3 times 3, or x to the 9th power, divided by 3 to the 3rd power, and y squared to the 3rd power, or y to the 2 times 3, y to the 6th power. And I'm going to write that out actually. So x to the 3 times 3, 3 cubed, y to the 2 times 3, x to the 9th, 3 to the 3rd power, 3 times 3 is 9, 9 times 3 is 27, y to the 6th. For number 3, we have 6x squared divided by 5y cubed. Nothing can combine or simplify here yet, so I'm going to distribute my exponent 2 to all pieces. 6 squared, x to the 2 times 2, 5 squared, y to the 3 times 2. 6 squared is 36, x to the 4th divided by 25, y to the 6th. And 36 divided by 25 cannot simplify, so I can leave those coefficients as is. For number 4, I have 2x squared. So this is essentially 2x times 2x. 2 times 2 is 4. X times x is x squared. That is our final answer. But we could also think about this as the 2 being distributed to both pieces. 2 squared, x squared, 4x squared. So the same thing with number 5, 2x to the cubed, or 2x cubed, 2x to the 3rd power. I could think about expanding this so that it is 2x times 2x times 2x. 2 times 2 times 2 is 8. X times x times x is x cubed. But I don't have to write it out like that. I could just think about distributing my 3 to both pieces. 2 cubed, or 2 to the 3rd power, is 8. X to the 3rd power is x cubed. Then we have 2x squared to the 3rd power, so a little different than 4 and 5. So for this one, I'm just going to distribute my exponents. 2 cubed times x squared to the 3rd power. When that happens, we're going to multiply our exponents. So I've got 2 cubed is 8, x to the 6th. And I could write that out, so 2x squared times 2x squared times 2x squared, 2 times 2 times 2 is 8, x squared times x squared times x squared is x squared plus 2 plus 2. When I'm multiplying, I'm adding my exponents, so x to the 2 plus 2 plus 2 is indeed x to the 6th power. For number 7, we have 1/3 out front. It's not included in the parentheses, so 1/3 is not being raised to the 3rd power here. It's just 1/3. So I'm going to keep 1/3 out front. it's just y squared being multiplied 3 times. 2 plus 2 plus 2 is 6. 1/3 y to the 6th, which they could have realized 2 times 3 is 6. Number 8, now 1/3 is included in the parentheses, so 1/3 is being multiplied 3 times as well. So I have 1/3 y squared times 1/3 y squared times 1/3 y squared 3 times. 1/3 times 1/3 times 1/3 is 1/27th. Y squared plus y times y squared times y squared, y to the 2 plus 2 plus 2, which is y to the 6th. And then the last one is not a fraction, it is a -3. -3y squared times -3y squared times -3y squared. -3 times -3 times -3. -3 times -3 is positive 9. Positive 9 times -3 is a -27. Y to the 6th. And for this last one, I'm not going to write this out 6 times. I'm just going to remember to distribute my exponent of 6 to every single piece. So I like to draw arrows like this. -2 to the 6th power. I keep that as is for now. -2 to the 6th power. M to the 6th. N to the 3 times 6 is 18. Y to the 4 times 6 is 24. Z to the 5th times 6 is z to the 30th. Now -2, since the negative isn't being included in the parentheses, we have -2 times -2 times -2 and so on. Whenever we have an even exponent, the final power will be positive, even if we start with a negative. And -2 to the 6th power is 64. 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32, times 2 is 64. M to the 6th, N to the 18th, Y to the 24, Z to the 30th. Nothing else can combine or simplify. For number 11, we have a negative again, and now it's to a 5th power, so the negative is going to stay negative. A negative to an odd power stays negative. Negative times a negative is a positive, times a negative is a negative. That was only to the 3rd, but it works the same to the 5th. Okay, so I have -1 to the 5th power is 1. 2 to the 6th power was 64. 2 to the 5th power is 32. M to the 2 times 5 is 10. N to the 3 times 5 is 15. Y to the nothing, but not really nothing, it's y to the 1st. Y to the 1st to the 5th, y to the 5th. Z to the 4 times 5 is 20. Let me know if you want to see any other examples down below.